Okay, so we're talking about graphing polar coordinates. And so to start off with, let's talk about, let's review or just go over something that's familiar with us, which is like plotting in regular, like a regular sine curve in our Cartesian coordinates. So if we're going to plot like sine of theta, so like typically we'd say y is equal to sine of theta. And so if we did this and we did a graph of we have theta and we have y, we would come up with these values. And so just to review, if you had like a point right here, you make kind of a triangle. And if this is theta, then the sine is, this is a unit circle, this is 1. And so this sine of theta would be this coordinate here, which we would say like is y, over the hypotenuse, which is 1. Or we could just say y is equal to sine of theta, right? So that's the y step. And then this right here, this component would be the adjacent. So like cosine of theta is your adjacent over the hypotenuse, which is 1. And so cosine of theta would just be this x value, right? So just to review that. But now if we look at this and we say, okay, sine of theta. And so as we go around the circle, we would plot it. So at pi over 2 right here. Well, actually, let's start with 0 at 0 degrees or 0 radians right here. The sine or the y value is 0. So we write 0 here at pi over 2 right here. And then we know that the y component is going to be 1. And so we put 1 here. And then if you keep going around the circle, when you get to pi, it's 0. When you get to 3 pi over 2 here, it's -1. And then we finally get back to, we can change the colors. We finally get all the way back to here at 2 pi. Then sine value is 0. And so if we plot this on this right here, we can plot our theta here and our y here, and you end up getting a sine curve that looks like this. You start at 0, you pick a point here, point here, point here, point here, and you connect it so that it looks like a sine curve. Okay? So now we know how to do that. Now we're going to go into graphing polar coordinates. Now, so in a polar coordinate, instead of saying y equals sine of theta, you would instead say r equals sine of theta, which looks very similar to y equals sine of theta. So our same plot values here apply, except now instead of theta and y, you're going to have theta and r. So we can use those same points and we put it down here. Now in polar, what you're doing is you take the first value, which is your theta, and you look at that. So like here, when theta is 0, that would be looking like this, right? And so the value, the theta is the angle at which it is, and then the r is how far it is going to be on that line. So when theta is 0 on this line right here, and r, then the point would be right here. I'm going to change colors. R would be like this point right there. Now if we go to pi over 2, we would, then that line would be something like this. That would be right here, right? This is our pi over 2 line. So at pi over 2, the value is 1. So if we go up 1, that would be like this. Now that doesn't give us a whole lot of information, okay? Like what's going on between here and here. So we can go up to this, and you can see that it's going from 0 all the way up, it's continuing to increase all the way up to 1. So if you picked a point somewhere in the middle, let's say at pi over 4, then we would plot that at pi over 4. That's our theta is pi over 4. You can say that it may not be exactly half, but it's somewhere between, between 0 and 1. And so if this was like our 1 value here, our point is going to be somewhere more like in here. Okay, and then if you picked up a point closer to pi over 2, like let's say pi over 3, something like that, it's going to be closer to 1. It's going to be like this. And if you picked a point at pi over 6, see this is pi over 6, pi over 4, pi over 3. At pi over 6 down here, right here on this, you can see that it's not 0, it's between 0, it's getting bigger, but it's still pretty close to 0. So that point would probably be something like this. So if you were to plot this, it might look something like that. Okay? Now, as you go from pi over 2 down to pi, you can see that you're going from 1 down to 0. And so we could do a similar thing where we have, now we're at 2 pi over 3, 3 pi over 4, 5 pi over 6. And if you look at those, are going to be symmetric to this side. So it's going to look something like that. Okay? That's not a very clean plot, but if you did it on like a real graphing calculator, it would look like a circle. And you can see, now here's the interesting thing is, okay, that brings us all the way down to pi. So we've checked this one off, and this one off. Now when you get to 3 pi over 2, it says -1. What does that mean? Okay, so here, if we go to 3 pi, I'm going to use a different color. If we go to 3 pi over 2, this is 3 pi here, right? And it's going in this direction, right? So if it said 1, it would be, the point would be down here. But it doesn't say 1, it says -1. So if this is the direction of 3 pi over 2, -1 would be going the opposite direction. So -1 on 3 pi over 2 is actually this point right there. And so if you plot the points from here to here and from here to here, what you'll see is, because now you're going like this direction, they're all going to be negative, and they're going to be retracing the points that we already made. And so you're just going to be going around the circle a second time. Okay, that's it for this.